In this video, the learner will use angle relationships to solve problems. First, we're going to talk about several angle relationships that we're going to study in this class. First is adjacent angles. These are coplanar angles that have a common vertex and one common side, but no common interior points. So we see angles BAC and CAD here that share a vertex, vertex A, so point A, and they also share a side. Ray AC is shared by both of them. So we would say BAC and angle CAD are adjacent. Next we have vertical angles. These are two non-adjacent angles formed by two intersecting lines. Notice it uses the word non-adjacent, so they will not share a side. So here we have angles 1, 2, 3, and 4. Angles 1 and 2 are across from one another with those intersecting lines, and 3 and 4 are across from one another. These pairs are our vertical angle pairs. So we would say angle 1 and angle 2 are vertical angles, and angle 3 and angle 4 are vertical angles. Next we have linear pairs. These are two angles that are adjacent to one another that will form a line. That's why we have the name linear pair. It's a pair of angles that form a line. Next, we're looking at a couple more relationships for complementary angles. These are angles that will add to 90 degrees. So we can see here the 60 and the 30-degree angles. If we added those together, they will be 90. Next are supplementary angles. These are two angles that will add to 180 degrees. Notice here, if those two angles form a linear pair, they will be supplementary because they would make a straight angle or a line. Lastly, we have perpendicular lines. These are lines that will intersect and form 90-degree angles. Next, we're going to take a look at a couple of examples here. We're going to name two sets of adjacent angles from this diagram here. Point D is that vertex point here, and then points A, B, and C are on each of the rays. From this diagram, I want you to name a set of vertical angles. And then I also want you to answer these two questions. Are angle AEB and AED a linear pair? So from this diagram, do those angles form a linear pair? And would all supplementary angles also be linear pairs? Next, we're going to take a look at a postulate and theorem that we're going to be using with angle relationships. The first one is the linear pair postulate. If two angles are a linear pair, then the angles are supplementary. So here we have angles 1 and 2 that are a linear pair. That's given information from this diagram, that we have line M and angles 1 and 2 are formed on that line. So we know from our diagram that 1 and 2 are a linear pair. What I want to do next here is actually prove the relationship that is true with angles 1 and 2, that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. So I have this little proof template here with statements and reasons that I'm going to be filling in. I know from my diagram that angle 1 and 2 are a linear pair. That's given information. Because I know they're a linear pair, by the linear pair postulate, I know 1 and 2 are supplementary. Because 1 and 2 are supplementary, that relationship tells me the measure of angle 1 plus the measure of angle 2 equals 180 by that definition. So we've proven that relationship using the linear pair postulate. For an example, if the measure of angle 2 equals 42 degrees, what would be the measure of angle 1? Next is the vertical angle theorem. If two angles are vertical, then the angles are congruent. So here we can see angles 1 and 2 and 3 and 4 are our sets of vertical angles. So we know angle 1 would be congruent to angle 2, and angle 3 is congruent to angle 4. So if the measure of angle 4 is 142 degrees, what would be the measure of angle 3? Go ahead and extend that a little bit and go ahead and find angle 1 and angle 2's measure. Next, we're going to take a look at actually proving the vertical angle theorem. So given 1 and 2 and 2 and 3 are linear pairs, we're going to prove angle 1 and angle 3 are congruent. We know from this diagram angle 1 and angle 3 are vertical angles. So we're hoping that we can actually prove what the vertical angle theorem states, that if these are vertical angles, then they should be congruent. So we always want to start with our given information. So our first piece of given information is that 1 and 2 are a linear pair. 1 and 2 being a linear pair means that angle 1 and 2 are supplementary by the linear pair postulate. We also know that 2 and 3 are a linear pair from our given information. And 2 and 3 being a linear pair means those are supplementary by the linear pair postulate. Now we've shown some relationships here between angles 1 and 2 and 2 and 3. So because we know they're supplementary, we know the measure of angle 1 plus the measure of angle 2 equals 180. And we know the measure of angle 2 plus the measure of angle 3 equals 180. Both because of the definition of being supplementary. Notice here that both of these equations equal 180 degrees. Because they both equal the same thing, I can substitute in one of those things for 180 degrees here. So my next statement can say 1 plus 2 is equal to 2 plus 3 by substitution. Notice I have the measure of angle 2 on each side of that equation. I can actually subtract that measure out. What I have left then is the measure of angle 1 is equal to the measure of angle 3 by substitution. And because I know the measures are equal, I know the angles are congruent by the definition of congruence. So what we've done here in this two-column proof is proven what the vertical angle theorem shows, that because angles 1 and 3 are vertical angles, they have to be congruent. This is a proof for that theorem. Remember, the difference between a theorem and a postulate is that a theorem has to be proven. Next, I have some examples. I want you guys to read through these, draw the pictures, and work them. And then here's 3 and 4.